Hello students. Well, for today's class, I would like to continue the numericals of dual nature of matter and radiation. So as you know that this chapter is very important as per the competitive examination is concerned, and even theory examination is also concerned. So please remember that this topic will be for 5 marks. So this 5 marks he may ask in any way. Either he will put 1 mark question, as well as he will put some 3 marks question, and sometime he will ask 2 mark as well as 3 marks. So sometime he is going to ask a 5 marks full question regarding experimental study of photoelectric effect, or regarding Einstein's theory of photoelectric effect, or else he may ask about the de Broglie's hypothesis about matter waves. So like that, or he may ask regarding laws of photoelectric effect. So he will ask about the failure of wave theory. Remember here, the chapter is very simple, okay, and this topic is not that much complex. So very simple theoretical aspects are there. So just if you go through all the theoretical aspect and all the mathematical equation pertaining to this, and then the numerical will also quite simple. So it will be easier for solving the numericals. So that is the reason you have to recall all the previous equations what we have discussed till today. Okay, so now we are going to take the numerical session. So already in the numerical session, already in my previous session, while explaining about division and Germer experiment for wave nature of electron, so there I took some 3 numericals, and remember that division and Germer experiment will not be there for the examination. Whatever the explanation I have given, that all the details will not be there in the syllabus. This is for an extra information to you. And remember, but outcome of that experiment is important. 1 mark important will be there for that. So what is that? So what is the outcome of division and Germer experiment? At the time you supposed to give the answer, wave nature of electrons. Okay, so that much will be the importance of that. So no detail of that experiment or explanation dealt with that experiment will not be given for any examination. But don't think that only we have to read for the purpose of exam. So it will give you some idea regarding the wave nature associated with the electron. But why I am speaking about the marks? So because in every student's mind there will be a one question: what should be the weightage of this, and what questions we can expect, what part is an important. For that purpose I am explained. Okay, so that is the reason I am going to say you. So otherwise you have to study whole and each part of the lesson, because every part of a lesson will give you some new ideas regarding the concepts. Okay, so with this I don't want to speak much, so I want to go to the topic. So anyhow, now we shall go for the further numerical. So that is 4th numerical. So I think in my previous class I was given you the solution of 3 numericals. So now I am going to explain the continuation of that answer for 4th. So question is there with me only, and even I am saying answer for 4th. Let it be. If you have a textbook, if it possible to have it, so then you can, or else just you listen the question here, and even I am going to write data before going through the answer of this question, and if with the help of that data and with that just you can go through the solved steps, then you can get the idea what we have to solve there. So for the 4th numerical, electron is emitted with 0 velocity from certain metal surface where it is exposed to a radiation of wavelength 6000 angstrom, then calculate threshold frequency and work function. So what is the question here? Electrons are emitted with 0 velocity from a certain metal. So it means there is some metallic surface. From that metallic surface the electrons are ejected with 0 velocity. Electrons are ejected with 0 velocity. So 0 velocity from the certain metal surface, and remember, when that metallic surface is exposed, when this metallic surface is exposed with a radiation of wavelength 6000 angstrom, this is very important, angstrom, then calculate, so what is threshold frequency, that is nu naught, and what is work function phi naught. Very simple question. Okay, so what is the question here? there is a certain metallic surface. From this surface, the electrons are ejected with zero velocity. When the surface is exposed with a radiation of wavelength 6000 angstrom, then what should be the threshold frequency of this and what should be the work function of this material? See here, we know that here energy of the photon, say if you take energy of the photon, or else we know that nu naught is equal to C by lambda naught. C by lambda naught. From this equation, C means 3 into 10 to the power of 8 meter per second. Lambda naught means 6000. Lambda naught you can take 6000 into 10 power minus 10 meter. Then minus 10 meter. If you simplify this, nu naught equal to C by lambda naught. So why we have to use this relation? See here, radiation of wavelength is there. So this wavelength of radiation, when it incident on this metal, the electrons are ejected with zero velocity, means this is the minimum condition, minimum wavelength. So it is the minimum condition. Okay, so it is the minimum condition, not minimum wavelength here. It is the minimum condition for this metal for the ejection of electron. So what is the minimum frequency? So it means it has minimum frequency. So minimum frequency means that minimum frequency we called as threshold frequency for the ejection. Just ejection will be possible. When you incident this frequency, ejection will be possible. Okay, so at that condition we treat the velocity of the electron will be zero. Therefore, I am using this equation, the equation which connects the velocity of the light with its frequency and wavelength. So this equation I am using, nu naught is equal to C by lambda naught, velocity of light divided by wavelength. So therefore, if you simplify this, what is the answer you are going to get here? So you are supposed to get 5 into 10 to the power of 14 hertz. 5 into 10 to the power of 14 hertz. Nu naught is equal to 5 into 10 power 14 hertz. This is the threshold frequency. Next, what they are asking? Work function. So work function, what is work function? It is the minimum energy required for the electrons in order to escape from the metallic surface is called work function, that is phi naught. It is given as h nu naught. So here h means Planck's constant, 6.625 into 10 raised to minus 34 into nu naught. What is nu naught? 5 into 10 to the power of 14. 5 into 10 to the power of 14. So students, this is work function. If you simplify this, okay, if you simplify this, you will get work function. Work function is nothing but the what? It's nothing but a term dealt with energy only. So therefore, you are getting work function here. It is okay. Another one point I supposed to tell here. So if you simplify this, you are getting answer in joules. Okay, but we require to convert this value in terms of electron volts. Already I told how to convert electron volt. Say we know that 1 electron volt is nothing but the what? 1 electron volt is nothing but the what? It is equal to 1.6 into 10 power minus 19 joule. What is 1 electron volt? It is the energy gained by the electron when it is accelerated. When it is accelerated under potential difference of 1 volt, then it acquires 1.6 into 10 power minus 19 joule. So it means, so here it has some joules. So in terms of electron volt I want to express. At that time what you are supposed to do? You have to divide this value by 1.6 into 10 power minus 19. So if you divide this value by 1.6 into 10 power minus 19, then you will get the electron volt, and that value will be, so 2.068. Work function is 2.068 electron volt. Okay. Next. So further numerical. The fifth one, an electron mass me, which is very important numerical. This numerical, the fifth one they have asked in CET. Once they have asked in CET, okay, we shall go through that. So I believe that you people are noting all this data and the numericals. So or else you can go through the textbook. Okay, you will get the solutions of this. So once again, the fifth numerical, answer for fifth. Okay, the fifth question is, an electron of mass me and a proton of mass mp mass of proton mp are moving with the same velocity. It means velocity of electron is equal to velocity of proton. Are moving with same velocity means same speed, full stop. What is the ratio of their de Broglie's wavelength? Then what is the ratio of de Broglie's wavelength? So they are asking you the ratio between lambda e to lambda p, and provided that the condition is the mass of the electron is me and the mass of the proton, that is mp, they are moving with the same speed. It means ve is equal to vp. Then what is the ratio of their de Broglie wavelengths? This is CET question. Okay, this they have asked in CET. See, very simple. We know that the wavelength equation associated with the photon, and even it can also be used for a particles, material particles, and that generalized equation we call as de Broglie's wave equation, wavelength equation. Lambda is equal to h divided by m, v. So here if I write, it becomes ve. So I will write if me, it becomes mass of the electron. So therefore this I am going to take it as lambda e. So I call this equation as 1. See, next lambda p is equal to h divided by mp vp. See here, ve, vp, h as well as this h as well as ve and vp are same. Then what is the condition you are getting here? That lambda e is inversely with what? me. And lambda p is inversely with what? mp. This conclusion we are getting. These becomes constants here, h by ve and this one. So obviously we know that wavelength will be short for heavier mass particles, and wavelength will be for electron, they are telling, for electron and proton. Yes, obviously this equation for a material particle. So we know that heavier mass particle has got shortest wavelength and lighter mass particle has got higher wavelength. Okay, lighter mass particle has got some higher wavelength. So wavelength value will be more. From these two equations, suppose if I divide this equation 1 as well as 2, suppose if I divide equation 1 and 2, what I am getting? Lambda e divided by lambda p is equal to lambda e divided by lambda p is equal to lambda e divided by lambda p is equal to, that is mp divided by me, mass of the proton. Yes, another one condition here I forgot to give you the data. Mass of the electron they gave, that is 9.1 into 10 raised to minus 31 kg, and mass of the proton they have given, that is 1.6 into 10 raised to minus 27 kg. Okay, mass of the proton and mass of the electron they have given. So mass of a proton, that is, what is the mass of a proton? 1.67 into 10 raised to minus 27 divided by 9.1 into 10 raised to minus 31. If you simplify, you will get a number. I think you are getting one value here. It is 1836. Lambda e by lambda p is equal to, so it means wavelength of the electron is 1836 times that of the proton. So it means wavelength of the electron is more by how many times? 1836 times of proton. Why? Because of this. Light mass, maximum wavelength. Okay? Note down. So don't waste your time in this lockdown. Go through all the classes of this college, what we are daily uploading in YouTube. Just go through all the classes. So anyhow, in this pandemic, we all the lecturers are doing this one session of taking the classes every day. So please make use of this without wasting your time. So get involved in the concept. Try to go through the numericals correctly. Okay, without wasting your time, you could feel that you are in college itself. So like that you have to study every day. Don't waste time, because we don't know what decision will come from government. So maybe in August, whether the college will begins or not, still everything is in a discussion. So at the time, at least without wasting this schedule, so daily we are uploading, I think 4 classes. Go through these 4 classes and make use of this. Okay? Yes. So ಕನ್ನಡ ಮೀಡಿಯಮ್ ಸ್ಟೂಡೆಂಟ್ಸಿಗೆ ಸ್ವಲ್ಪ ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತಿರ್ಬೋದು ಅಂತ ಅನ್ಕೋತೀನಿ. ನ್ಯೂಮರಿಕಲ್ಸ್ ನೀವು ಸ್ವಲ್ಪ ಕರೆಕ್ಟಾಗಿ ಯಾವುದಾದ್ರೂ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಇತ್ತಂದರೆ ಅದನ್ನು ಸ್ವಲ್ಪ ಒಂದು ಸತಿ ಥಿಯರಿನ ಓದ್ಕೊಳ್ರಿ. ನಿಮ್ಗೇನಾದರೂ ಗೊತ್ತಾಗಿಲ್ಲ ಅಂತಂದರೆ ಸೊ ಒಂದು ಸತಿ ಯಾವಾಗಾದರೂ ಮತ್ತೆ ರೆಗ್ಯುಲರ್ ಕ್ಲಾಸಸ್ಸಿಗೆ ಬಂದಾಗ ನಾವು ಅದನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋಣ ಅಂತ. ಓಕೆ, ಸೊ ಎಲ್ಲ ನ್ಯೂಮರಿಕಲ್ಸ್ ಕರೆಕ್ಟಾಗಿ ನೋಡ್ಕೊಳ್ರಿ. ಹಾಗೆ ಈ ಚಾಪ್ಟರ್ನಲ್ಲಿ ಮಾತ್ರ ನಿಮಗೇನು ಕಷ್ಟ ಆಗಲ್ಲ, ಯಾಕಂದರೆ ಭಾಳ ಸಿಂಪಲ್ ಈಕ್ವೇಷನ್ಸ್ ಇದ್ದಾವೆ. ಆ ಈಕ್ವೇಷನ್ಸ್ ನಿಮಗೆಲ್ಲರಿಗೂ ಕೂಡ ನೆನಪಿರುತ್ತೆ. ಇಸ್ ಇಟ್ ರೈಟ್? ಸೊ ನೆಕ್ಸ್ಟ್ ಐ ಥಿಂಕ್ ವಿ ಶುಡ್ ಸ್ವಿಚ್ ಆನ್ ಟು ದಿ 6th ನ್ಯೂಮರಿಕಲ್. ಆನ್ಸರ್ ಫಾರ್ 6th. Calculate, directly they have given, calculate what we have to calculate. Number 1, momentum of whom? Momentum of electrons. Electrons are nothing but what? Photoelectrons. And de Broglie wavelength, second de Broglie wavelength of electrons when they are accelerated by potential difference of 56 volt. Given data they have given. So what is the data they have given means? The question is very simple. Calculate the momentum of the ejected electrons from the certain metallic surface, and correspondingly after the calculation of the momentum associated with the electron, you also calculate what is the wavelength associated with the electrons. Suppose if that electrons are subjected for the acceleration by applying a potential difference of 56 volt. By applying a potential difference of 56 volt, under this condition, what should be the wavelength? What should be the de Broglie's wavelength for electrons? Question is very simple. Calculate momentum of the electrons. So it means with what velocity the electron, with what momentum, yes or no? So mass of the electron and just with velocity of the electron, with what velocity those electrons are moving. So that if you, then momentum of the electrons, we need to calculate momentum of the electrons. For this they have given second de Broglie wavelength of the electron accelerated by a potential difference of 56 volt. So for this, see here, the momentum of the electron is given by, we know that first I will write the data, what are the given. So in order to calculate this, they have given the data here. So first they have given here 56 volt, okay, accelerating potential. Follow the data. Second, they have given Planck's constant 6.625 into 10 raised to minus 34 joule second, and they have given the next one is mass of the electron, that is 9.1 into 10 raised to minus 31 kg, and next they have given charge of the electron 1.6 into 10 raised to minus 19 coulombs here. Okay, so with this data we need to calculate what is the momentum associated with the electron. See here, we know that the equation, that's kinetic energy is equal to EV. Yes or no? When an electrons are accelerated under this potential difference, then they acquire the what? Maximum kinetic energy. So therefore half mv is equal to EV. So this is small v, this is v. This implies square here. So this implies what we need to calculate here, only I want to calculate mv. Therefore mv square is equal to 2EV, or mv is equal to, because I want the momentum here. So therefore mv is equal to, what is the answer? mv is equal to root of 2EVm. Yes sir, no? Root of 2EVm. So root of 2EVm. Yes. So here 2 into electron, charge of electron 1.6 into 10 power minus 19. Accelerating potential, that is obviously 56 volt, yes 56, into mass of the electron 9.1 into 10 power minus 19. First every time I told you that while solving the numericals, first you simplify the powers, later on you go for multiplication, and if possible you take the square root of it. Okay, then next you put the solution for this. So what is the value we are getting after solution means? So you are going to get, that is 4.02 into 10 raised to minus 24 kg meter per second. Kg dealt for mass, meter per second for velocity. Okay, so kg meter per second, which is an SI unit here. Gram centimeter per second in CGS. This is momentum. What is the next? Corresponding to this 56 volt, what should be the wavelength associated with the electron? We know that. Not we know that. Yes or no? We know that de Broglie wavelength is given by, very simple, 12.27 divided by root v. What is root v? Not velocity, accelerating potential. So therefore 12.27 by root 56. If you solve this, the wavelength, already you know what is the wavelength range calculated by de Broglie for electron, that is 1.66 angstrom. Keep this in mind, and your value should be obviously either exactly 1.66 or else close to this value you may get, because we calculated that 1.66 for 54 volt. This is for 56 volt. So it means some small variation will be there. So what is that? 56 volt means high energy. Yes or no? High energetic particles. For higher energetic particles, wavelength becomes short. Here 56 means 54 1.66. For 56 what? It should be less than 1.66. So therefore answer is 1.64 angstrom. Is it correct or no? Yes. Well, lambda is equal to 1.64. See, it is true. Okay. Okay, this is the answer for 6th numerical. Students, go through the data correctly, and it requires only remembering some mathematical equations. If you can't remember the equations, you can't get the solution for the numericals. Okay, so here very simple, why I used this equation means because the electrons are subjected for 56 volt of acceleration. Under this condition, what is the momentum? So therefore very simple, kinetic energy is equal to EV. Because why I have to take this equation? Okay, so this equation why I have to take means because accelerating potential is there, corresponding to that they have momentum, means they have definitely kinetic energy. So kinetic energy is given by EV. Kinetic energy is half mv square, which is equal to EV. Therefore mv, if you take for only mv, then you can get momentum. So therefore this is the thing. And why we have to take this equation only, why not some other equation? Not necessary. For the accelerating potential they are asking you wavelength, so therefore only this equation is sufficient here. So we can also solve this by alternate methods, but this one is the method what I supposed to say. Okay, so now we shall go through the next numerical. Mundin numerical ಗೆ ಹೋಗೋಣ. See problem number 7 and solution to the 7th problem I would like to give right now. First I will tell you, okay, this is also a very simple question. So answer for 7th question. What is that? Find the maximum frequency. First of all only they gave find what? Maximum frequency. Maximum frequency and minimum wavelength. Second one is minimum wavelength. Obviously frequency is maximum, wavelength is minimum. Minimum wavelength. Find maximum frequency and minimum wavelength of what? Of X-rays. Of X-rays produced by of X-rays produced by 30 kilovolt electrons. It means when an electrons are subjected for 30 into 10 raised to 3 volt, it becomes 3 into 10 raised to 4 volt. So under this potential difference, if electrons are accelerated, then they will produce an X-rays, and corresponding to that X-rays, yes, we need to definitely here we have to take the what? Some crystal in order to eject the X-rays here. ಅಂದರೆ ಏನಿಲ್ಲಿ 30 ಕಿಲೋವೋಲ್ಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫ್ರೆನ್ಸ್ನಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಎಕ್ಸಲರೇಟ್ ಮಾಡಿದಾಗ ಸೊ ಅದರದ್ದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಎಷ್ಟಿದೆ ಮತ್ತು ಅದರದ್ದು ಮಿನಿಮಮ್ ವೇವ್ಲೆಂತ್ ಎಷ್ಟಿರುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನಿಂದಂತ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕು. ಸೊ ಇದಕ್ಕೆ ಕೊಟ್ಟಿರೋ ಡಾಟಾ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದರೆ ಪ್ಲ್ಯಾಂಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಪ್ಲ್ಯಾಂಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ದೇ ಹ್ಯಾವ್ ಗಿವೆನ್ 6.625. So Planck constant they have given here, it is 6.63. Okay, instead of 25 they have given 3 here. 6.63 into 10 raised to minus 34 joule second. So ಇಲ್ಲಿ ನೋಡ್ರಿ ಸ್ವಲ್ಪ ಕ್ವಶನ್ ಕರೆಕ್ಟಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ರಿ. They are asking you to find maximum frequency. So maximum frequency means what? This is proportional to Kmax. Yes or no? Kinetic energy is maximum. So we know that this Kmax is equal to what? EV. And this Kmax is proportional to frequency, that is h nu. Frequency of the photon, because we are taking frequency of the particle associated will be h nu. So therefore the energy associated with the particle we are taking it as h nu. Therefore h nu is proportional. Therefore h nu is proportional to Kmax, and which is also proportional to EV, means obviously this h nu is equal to EV. H nu is equal to EV. Is it true or no? Here it means ilodri kinetic energy maximum, that is EV. Andre ಸೊ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪೊಟೆನ್ಷಿಯಲ್ ನೋನ್ ಆಸ್ ಟಾಪಿಕ್ ಪೊಟೆನ್ಷಿಯಲಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿಯಿಂದ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ವಿಲ್ ಅಕ್ವೈರ್ ದಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಕಂಪ್ಲೀಟ್ಲಿ ದೇ ವಿಲ್ ರಿಪಲ್ ಫ್ರಮ್ ದಿ ಕಲೆಕ್ಟರ್ ಪ್ಲೇಟ್. ಯಾಕಂದರೆ ಆ ಕಂಡೀಷನಲ್ಲಿ ದೇ ವಿಲ್ ಕಂಪ್ಲೀಟ್ಲಿ ಲೂಸ್ ದೇರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ. ದಿಸ್ ಟರ್ಮ್ ಇ ವಿ ಈಸ್ ರೆಫರ್ಡ್ ಆಸ್ electrostatic potential energy of the electron, and this electrostatic potential energy completely converted into kinetic energy in order to repel the collector plate. So that is the reason K max equal to EV. And remember, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದೆ ಅಂದರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಕೂಡ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರುತ್ತೆ. ಸೊ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಈ ಕೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬದಲಾಗಿ ನಾನಿಲ್ಲಿ ಹೆಚ್ ನ್ಯೂ ಅಂತ ಬರೀಬೋದು. ಹೆಚ್ ನ್ಯೂ ಅಂತಲೇ ಯಾಕೆ ಬರೀತೀರಿ ಅಂತಂದರೆ, ಸೊ ವಿ ನೋ ದ್ಯಾಟ್ the incident radiation has got small packets of energy called quanta, and that is to be treated as a photon, and that photon has got h nu, where nu is frequency. So nu equal to ev, therefore nu is equal to e into v by h. Okay, e into v by h. So therefore e into v by h. So what is e? Charge of the electron, 1.6 into 10 raised to minus 19, subjected for what potential difference? That is 30 kilovolt. So 30 kilovolt ಇದೆ. ಫಸ್ಟ್ ಅದನ್ನು ನೀವು ವೋಲ್ಟಿಗೆ ತೊಗೊಂಡು ಬರ್ರಿ, ಕನ್ವರ್ಟ್ ದಟ್ ಡಾಟಾ ಟು ವೋಲ್ಟ್. ಸೊ ವೋಲ್ಟಿಗೆ ತೊಗೊಂಡು ಬರ್ರಿ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ, ವಿ ಈಸ್ ಈಕ್ವಲ್ ಟು 30 kilovolt. ಸೊ ದಿಸ್ ಇಸ್ 30 into 10 raised to 3 volt, or V is equal to 3 into 4 volt. So now frequency, maximum frequency I will write, nu max ಅಂತ ಬರೆದ್ಬಿಡ್ತೀನಿ ಬಿಡ್ರಿ. nu max equal to 1.6 into 10 power minus 19 into, that is 3 into 10 raised to 4 upon 6.63 into 10 power minus 34. If you simplify this, first you simplify powers, minus 19 4 plus 15, that is 10 to the power of plus 15. So therefore this minus 34, if you take to the numerator, becomes plus 34, then multiply 1.6 into 3, then it divide by 6.63. I think you will get answer 7.24 into 10 raised to 18 hertz. Frequency SI unit is hertz. Next, minimum wavelength. Remember here, if this is a maximum frequency means, what I can write here, h nu max, yes or no? Then it becomes what? hc divided by lambda minimum. If frequency is maximum, obviously wavelength is minimum. So therefore, once again, EV is equal to hc by lambda minimum. ಇದೇ ಈಕ್ವೇಷನ್ ಇಲ್ಲಿ ನೀವು ಅಂದರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ದಿ ರೇಡಿಯೇಷನ್ ಅಂತೀವಿ. ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ದಿ ರೇಡಿಯೇಷನ್ ಹೆಂಗೆ ರಿಲೇಟ್ ಮಾಡ್ಬೋದು? ವಿ ನೋ ದಟ್ ನ್ಯೂ ಈಸ್ ಈಕ್ವಲ್ ಟು ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ, ಆರ್ ವೆಲಾಸಿಟಿ ಆಫ್ ದಿ ರೇಡಿಯೇಷನ್ ಆರ್ ಲೈಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ನ್ಯೂ ಲ್ಯಾಂಬ್ಡಾ. ಸೊ ಅದಕ್ಕೆ ಇದನ್ನು ಬರೆದಿರೋದು. ಅಂದರೆ ಇಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗಿ, ಸೊ ಹೆಚ್ ಆ್ಯಸ್ ಇಟ್ ಈಸ್, ನ್ಯೂ ಅಂದರೆ ನಾನು ಏನಂತ ಬರ್ಕೋಬೋದು, ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ. ಯಾಕಂದರೆ ವೇವ್ ಲೆಂತ್ ಬೇಕಾಗಿದೆ ನನಗೆ, ಅದಕ್ಕೆ ನಾನು ಅದನ್ನು ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ದೇರ್ ಫೋರ್ ಇ ವಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ಹೆಚ್ ಸಿ ಬೈ ಲ್ಯಾಂಬ್ಡಾ ಮಿನಿಮಮ್. ಸೊ ದೇರ್ ಫೋರ್ the wavelength, so lambda minimum is equal to, so what it becomes, hc by ev. v is known, h is known, c is known, ಗೊತ್ತಿರಬೇಕದು ನಮಗೆ. 6.63 into 10 raised to minus 34 into c, 3 into 10 raised to 8, velocity of the light c ಅಂದರೆ. ಸೊ e ಅಂದರೆ ಚಾರ್ಜ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ 1.6 into 10 power minus 19. v ಅಂದ್ರೆ ಏನು? That is 3 into 10 power 4, accelerating potential. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿರಿ ಇದನ್ನು. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಾಗ ನಿಮಗೆ ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ವೇವ್ ಲೆಂತ್ ಬರುತ್ತೆ. ಸೊ ಐ ಥಿಂಕ್ ಯು ಆರ್ ಗೆಟಿಂಗ್ 0.041 into 10 raised to minus 19 meter. ಸೊ ನೀವು ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕು. ಇದನ್ನೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿಕೊಂಡು ನಾನು ಕೊಡೋ ಆನ್ಸರ್ ಕರೆಕ್ಟ್ ಇದೆ ಇಲ್ಲ ಅಂತ ನೋಡ್ಕೊಳ್ರಿ ಅಷ್ಟೇ. ಯಾಕಂದರೆ ಪ್ರತಿಯೊಂದು ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಇದು ಆಫ್ಲೈನ್ ಕ್ಲಾಸ್ನಲ್ಲಿ ಮಾಡ್ಬೋದು, ಬಟ್ ಆನ್ಲೈನಲ್ಲಿ ಮಾಡ್ಕೊಂಡು ಕೊಡೋಕ್ಕಾಗಲ್ಲ. ಸೊ ದೇರ್ ಫೋರ್ ಅದಕ್ಕೆ ನೀವು ಕೂಡ ಸ್ವಲ್ಪ ಅದನ್ನು ಮಾಡಬೇಕು. ಆಲ್ರೆಡಿ ನಿಮಗೆ ಗೊತ್ತಿದೆ, ನೀವು ಇವಾಗ ಸೆಕೆಂಡ್ ಇಯರ್ನಲ್ಲಿ ಇದ್ದೀರಿ. ನೌ ಯು ಆರ್ ಇನ್ PUC 2, 19 meter. ಸೊ ಬರ್ದಿದ್ದೀನಿ ನೋಡ್ರಿ ಇಲ್ಲಿ. ದಿಸ್ ಇಸ್ ದ ಥಿಂಗ್. Okay, this is the 7th numerical. So next, further, ಮುಂದಿನ ಪ್ರಾಬ್ಲಮ್ ನೋಡ್ರಿ. ವರ್ಕ್ ಫಂಕ್ಷನ್ ಆಫ್ ಸೀಸಿಯಂ ಮೆಟಲ್ ಈಸ್ 2.14 ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್. ವರ್ಕ್ ಫಂಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ? ವರ್ಕ್ ಫಂಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಯಾರ್ದು? ಸೀಸಿಯಂ ಮೆಟಲ್. ದಿ ವರ್ಕ್ ಫಂಕ್ಷನ್ ಆಫ್ ಸೀಸಿಯಂ ಮೆಟಲ್ ಈಸ್ 2.14 electron volt for cesium, not computer science, cesium. Okay, so next, metal is 2.14 electron volt when light of frequency 6 into 14 hertz, when a light of frequency 6 into 10 raised to 14 hertz is incident on the metal surface, then the photo emission of electron will be occur. Obviously, there is a one cesium metal surface. On this I am going to incident a radiation of this frequency, then electrons will be ejected and the electrons will be ejected. Photo emission will be takes place and the minimum energy that would be required for this surface to give the electron is 2.14 electron volt. Okay, fine. So now what they are asking? They are asking you to that maximum kinetic energy. So with what kinetic energy they are ejecting? We need to calculate kinetic energy. So number one, maximum kinetic energy. So we need to calculate maximum kinetic energy of electrons, photoelectrons only. Next, stopic potential VO. Next we need to calculate stopic potential VO and maximum speed of the emitted photoelectron. So third one we should calculate here maximum speed of electrons. It means we have to calculate velocity. Okay, so we know that kinetic energy we need to find. For that, work function of the surface they have given, and for that the frequency of incident radiation given. ಒಂದು ಸರ್ಫೇಸ್ ಇದೆ, ಆ ಸರ್ಫೇಸ್ ಮೇಲೆ ಎಷ್ಟು ಫ್ರೀಕ್ವೆನ್ಸಿ ರೇಡಿಯೇಷನ್ ಹಾಕ್ತೀವಿ, ಆವಾಗ ಅದರದ್ದು ವರ್ಕ್ ಫಂಕ್ಷನ್ 2.14 ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಇದೆ, ಅವಾಗ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್ ಆಗುತ್ತೆ. ಸೊ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಷನ್ ಆಗಬೇಕಾದ್ರೆ ಆಬ್ವಿಯಸ್ಲಿ ಈ ಎನರ್ಜಿ ಏನಿದೆ ಅಲ್ಲ, ಹೆಚ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದರೆ ಎನರ್ಜಿ ಆಗುತ್ತೆ. ದಿಸ್ ಎನರ್ಜಿ ಈಸ್ ಆಬ್ವಿಯಸ್ಲಿ ಗ್ರೇಟರ್ ದೆನ್ ದಿಸ್. ಓಕೆ, ಸೊ ದೆನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ejected with maximum kinetic energy. So now tell me which equation which connects with kinetic energy h nu as well as h nu naught? Obviously, which one? Einstein's photoelectric equation. Very good. So therefore K max is equal to h nu minus phi naught. Please go through phi naught value, that is not in joule, electron volt. So obviously this h nu should be divided with what? 1.6 into 10 power minus 19 joule to convert the value in terms of electron volt. Therefore K max is equal to h nu minus phi naught. So I will erase that side and now I am going to proceed. See, K max is equal to h 6.625 10 raised to minus 34. ಕೆಲವೊಂದು ಪ್ರಾಬ್ಲಮ್ನಲ್ಲಿ ಡಾಟಾ ಅದು ಕೆಲವೊಂದು ನೆಸಸರಿ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಕೆಲವೊಂದು ಟೈಮ್ ಕೊಟ್ಟಿರಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ನೀವು ಅದನ್ನು ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋದು ಬೆಸ್ಟ್. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದಿ ಸರ್ಟನ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವಿಚ್ ವುಡ್ ಬಿ ರಿಕ್ವೈರ್ಡ್ ವೈಲ್ ಸಾಲ್ವಿಂಗ್ ದಿ ನ್ಯೂಮರಿಕಲ್ಸ್. ಹೆಚ್ ಇಂಟು ವಾಟ್ ಈಸ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ? 6 into 10 power 14 upon 1.6 into 10 power minus 19 minus 2.14 electron volt. ನೀವು ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇದಿಷ್ಟೇ ವ್ಯಾಲ್ಯೂ ತೊಗೊಂಡ್ರೆ ಹೆಚ್ ನ್ಯೂ ಅಂತ ತೊಗೊಂಡ್ರೆ ಎನರ್ಜಿ ದಟ್ ಈಸ್ ಇನ್ ಜೌಲ್. ಸೊ ಯು ವಾಂಟ್ ಟು ಕನ್ವರ್ಟ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಅಂದರೆ ನೀವು ಡಿವೈಡ್ ಬೈ 1.6 ಮಾಡಲೇಬೇಕು. ಸೊ ಅವಾಗ ಈ ಒಂದು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಬರುತ್ತೆ, ದಟ್ ವ್ಯಾಲ್ಯೂ minus 2.14 electron volt you have to do. So what is the value you are getting means, for this the value you are getting is the 0.346 electron volt. ಕಂಪ್ಲೀಟ್ ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ರಿ. ಸಾಲ್ವ್ ಮಾಡಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದರೆ 0.346 ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್, ದಟ್ ಈಸ್ ಕೆ ಮ್ಯಾಕ್ಸ್. ಜೌಲ್ನಲ್ಲಿ ಬರೀಬೇಕಿತ್ತಂದರೆ ಎರಡು ಆಪ್ಷನ್ ಇದಾವೆ. ನೀವು ಇದನ್ನು ಡಿವೈಡೆಡ್ ಬೈ 1.6 into 10 power minus 19 ಆದರೂ ಮಾಡ್ಕೊಂಡು ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟಿಗೆ ಬರೀರಿ, ಅಥವಾ ಇದನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಬೈ 1.6 ಇಂಟು 10⁻⁻19 ಮಾಡಿ ಜೌಲಿಗಾದರೂ ತೊಗೊಂಡು ಬರ್ರಿ. ಜೌಲ್ನಲ್ಲಾದರೂ ಬರಿಬೋದು, ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ನಲ್ಲಾದರೂ ಬರಿಬೋದು. ಜೌಲ್ ಈಸ್ ಆಲ್ಸೋ ಆನ್ SI ಯೂನಿಟ್. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ವಾಟ್ ಎಕ್ಸ್ಪ್ರೆಸಿಂಗ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಪೊಟೆನ್ಷಿಯಲ್. ದಟ್ಸ್ ಆಲ್. ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಆಕ್ಸಲರೇಟಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ನಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋದು ಅಷ್ಟೇ. ಸೊ ನೆಕ್ಸ್ಟ್ ವಾಟ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಯು, ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್. ವಿ ನೋ ದ್ಯಾಟ್ Kmax is equal to what? EVO. Yes or no? We know that they are associated with maximum kinetic energy when they are at stopping potential, when accelerating potential is VO. Therefore, ಇಲ್ಲಿ ನೋಡ್ರಿ EVO ಇರೋದ್ರಿಂದ Kmax is already in terms of electron volt. Therefore, what is EVO? Therefore, VO ಏನಾಗುತ್ತೆ ಇವಾಗ obviously 0.346 volt. 0.346 volt. ನೆಕ್ಸ್ಟ್ ಏನು ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು, ಸ್ಪೀಡ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್, ಮ್ಯಾಕ್ಸಿಮಮ್ ಸ್ಪೀಡ್ ಅಂತ. ಸೊ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಮೀನ್ಸ್ half m Vmax square is equal to half m Vmax square is equal to EVO. ನಿಮಗೆ ನೋಡ್ರಿ ಹಾಫ್ ಎಮ್ ವಿ ಮ್ಯಾಕ್ಸ್ ಸ್ಕ್ವೇರ್, ಇದನ್ನು ನಾನು ಈ ರೀತಿನೂ ಬರಿಬೋದಾ, ಹಾಫ್ ಎಮ್ ವಿ ಮ್ಯಾಕ್ಸ್ ಅಂತ. ಸೊ ಅಂದರೆ ಏನಾಯಿತು, ಹಾಫ್ ಎಮ್ ವಿ ಮ್ಯಾಕ್ಸ್ ಅಂದರೆ 0.346 ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್. ಸೊ ಇ ವಿ ನಾಟ್ ಅಂತಲೂ ಬರ್ಕೋಬೋದು. ಸೊ ಅಥವಾ ಇ ವಿ ನಾಟ್. ಸೊ ಇದು ಕೂಡ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ. ಸೊ ಸ್ಪೀಡ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಯು, ಸ್ಪೀಡ್ ಕೇಳ್ತಾ ಇದ್ದಾರಾ. ಸೊ ದೇರ್ ಫಾರ್ ದ್ಯಾಟ್ half m Vmax square equal to EV naught. Therefore, Vmax is equal to EVO by, that is 2 EVO by m under the root. Yes or no? 2 EVO by m. Then this EVO, that is Kmax. Then what this becomes? Square root of ಏನಾಗುತ್ತೆ ಅವಾಗಿದು 2 EVO. EVO ಅಂದರೆ Kmax ವ್ಯಾಲ್ಯೂ. ವಾಟ್ ಈಸ್ ದಟ್? 0.346 ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್. ಸೊ ದೇರ್ ಫೋರ್ ಅದನ್ನು ತಗೊಂಡು, ಸೊ ನೆಕ್ಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡಿವೈಡ್ ದಿಸ್ ವಿತ್ ಮಾಸ್ ಆಫ್ ದಿ ಎಲೆಕ್ಟ್ರಾನ್ 9.1 ಇಂಟು 10 raised to 2 ಇಂಟು 0.346 ಡಿವೈಡೆಡ್ ಬೈ 9.1 ಇಂಟು 10 raised to minus 34, 9.1 into 10 power minus 31 kg. Then if you simplify this, you are getting the value is 3.488 into 10 raised to 5 meter per second. ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದರೆ ಇದಿಷ್ಟು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ ನೋಡ್ರಿ. ಆ ವ್ಯಾಲ್ಯೂ ಏನಂದರೆ ಇಲ್ಲಿ ಬರೀತೀನಿ ನೋಡ್ರಿ, maximum velocity Vmax 3.488 10 raised to 5 meter per second. ಓಕೆ, ಇಷ್ಟು ವ್ಯಾಲ್ಯೂ. ಓಕೆ, ಸೊ ಇವತ್ತಿನ ಕ್ಲಾಸಿನಲ್ಲಿ we have discussed 5 numericals. Okay, so in my next class I will go through the further numericals. Okay, thank you.